question. Josh, would you read it, please?
Here's a graph for one equation in a system of equations.
Okay.
Write a second equation for the system so it has infinitely many solutions.
All right, so what does that mean if we're going to have infinite number of solutions?
Exactly.
The same line, right? So that means we got to figure out the equation of this line. So what is the slope of that line, Brody? What's that? Slope? What do you have in front of the x? You can't read it, or it's just super funny to you? Negative what? Yeah. Down 3 to the right 4. Negative 3/4. Now the y-intercept, Kaylee, where does it cross the y-axis? 4. Plus 4 or minus 4? Up 4, yes, ma'am. Do you have to have that one?
Yes.
Yeah, no other possible option you can have there. It's got to be the exact same equation as that. Remember, slope negative going down. Question B, write a second equation of graphs go through 0, 1 that has no solution. So that means the slope is the same, and I want it to go through this right here. Georgie.
Wait, is this the number like where the y-intercept can be anything?
Normally,
Okay.
but it tells us what the y-intercept has to be on this one.
That's why. Oh, okay. So y equals negative 3/4 x plus 1.
Yes.
Good God, that one.
Now, normally you could have anything you want back here, but this one is specific to go through this point. So it wants it parallel through that. So there's only one possible option for that one as well. Question C, write a second equation that goes through 0, 2. There's your y-intercept, so we already know that. We got to figure out the slope. So kind of a review here, Jared. How do we get the slope? Remember?
Well, I just looked at the graph and got the slope from looking at
You put the dots on there?
No.
Or you looked at this graph and just said, I know the slope?
Yeah.
Well, that's impossible. You'd have to at least know the points on this. All right, so to get the slope, you subtract the y's. 2 minus 1. 0 minus 4. And it doesn't matter where the negative goes again. Okay? Or if you're magical, you can just look at this and see that.
I knew the same.
All right, question number 2.
2 and then 4.
Create a second equation so it has no solution.
I thought that was supposed to be on the next
Kinley.
I said y equals 3/4 x minus
Yes. Doesn't matter what that thing is. Have anything you want there.
Let's go.
Question number 3, Kellen.
Andre is in charge of cooking broccoli and zucchini for a large group. He has to spend all $17 he has and can carry 10 pounds of veggies. Zucchini costs $1.50 per pound, and broccoli costs $2 per pound. One graph shows combinations of zucchini and broccoli that weigh 10 pounds, and the other shows combinations of zucchini and broccoli that cost $17.
All right, so first let's figure out which is which. So one of them, all the points on there, if you were to put all the dots on there, they would add up to 10. One of them would add up to 17. Do you know which is which? Colin?
The blue line is the cost.
And then the black one is pounds? And that was 10? Yes? Okay. So, name one combination of veggies that weigh 10 does it not cost 17. So that means it's on the black line, but it is not on the blue one. Jared.
10 zucchini and 0 broccoli.
Yeah, that would not cost $17. I probably should write it out. 10 zucchini, 0 broccoli. 10 pounds. Okay, B, name one combination of veggies that cost 17, but it does not weigh 10 pounds. So now it's on the blue line, but not on the black one. Josh.
10 pounds of zucchini and 1 pound of broccoli.
What, 7 pounds of broccoli and 2 pounds of
Yeah, a lot of different options there. Just got to be on the graph. How many pounds of zucchini and broccoli can Andre get? So he spends all 17 and 10 pounds of veggies. So now that's would be where the two meet, right? Evan.
6 zucchini and 4 broccoli.
6 zucchini and 4 broccoli. Now it is on both lines. Question number 4. Kind of started on this one the other day.
I think I got this one.
In the Sahara Desert, temperature often reaches 50 degrees Celsius, so that means I'm plugging in 54 Celsius. So 9 over 5 times 50 plus 32. Can you cross cancel here at all? Yes. So 9 times 10 plus 32.
122.
That's 122 degrees Fahrenheit. Makes sense? You're in the desert. You're going to be hot. B, negative 60 degrees Fahrenheit. How many degrees Celsius is that? So now I'm plugging that in for letter F. Okay. So how do I get the Celsius by itself? I get rid of that 32. Subtract 32. So what is negative 60 minus another 32? Negative 92 equals a 9/5. See, now I got to get rid of that 9/5. You divide by it. Because right now you're multiplying by 9/5 times C. The opposite is divide by 9/5. So I got to take negative 92 divided by 9/5 or times 5 over 9. Can you cross cancel anything there? No. So Georgia, what do you get?
I got about negative 51 degrees Celsius.
Anybody confirm that?
Yes.
Yeah? All right. I'm not even going to do it then. About?
Yeah.
Fif-
It's like negative 51.1 repeating.
Yeah, so just 0.1.
0.1 repeating? I think that's 1/9. You could have done a fraction then too. Either way, we said about, so that's fine. Okay, how about this guy? This is where we left off. Gotta get the C's the same side. So let's get rid of this one. How do you get rid of that? Colin?
I turned 9/5 into 1.8.
All right. Rather have decimals? That's fine. That's fine.
And then subtract 1.8 from
So what is 1 minus 1.8?
negative 0.8.
Negative 0.8.
And then divide 32 by negative 0.8, and that's negative 40.
Negative 40. So that's the only temperature where Celsius equals Fahrenheit. It's the only one.